Zincox Resources is a technology-driven British company set up in 1998 to recover zinc from unconventional sources. The company's focused on the production of a high-quality zinc oxide chemical by processing furnace dust generated by the steel industry. Following several years of research and development, its first plant was built in South Korea in 2012. The Korean operation demonstrated the effectiveness of the core process behind the technology, the rotary hearth furnace. This splits the dust into two intermediate products, a zinc-rich fume that is filtered out of the off-gas and an iron-rich metal-bearing briquette. Laboratory test work and piloting has demonstrated that both these intermediate products can be upgraded to produce added value final products and various byproducts, so that there is no solid waste. New plants will therefore consist of the core rotary hearth technology together with additional facilities to upgrade its outputs to final products. The zinc oxide will be recovered using Zincox's proprietary CML process, a transformation that is only possible due to the exceptional quality of the zinc fume. The iron will be recovered in a simple electric melting furnace.
We refer to this no-waste process as the full cycle technology. It generates more revenue and is more environmentally sustainable than existing processes, and it therefore represents a breakthrough both environmentally and economically. Zincox is now rolling this process out around the world, and the first full-cycle plant is under construction by Korea Zinc in Vietnam. The plant is designed to treat 100,000 tonnes a year of steel furnace dust for the production of about 30,000 tonnes of high-quality zinc oxide chemical, suitable for the ceramics and rubber industries.
The feed for the full-cycle process is a waste dust generated by the recycling of iron and steel scrap in electric arc furnaces. About 1/3 of all steel is produced in this way. Due to the increasingly galvanized nature of scrap, this electric arc furnace dust is rich in zinc. The dust also contains a significant amount of iron, salt, and other base metals. There are over 6 million tons of this dust produced annually around the world, containing over 20% zinc, a far greater concentration than most zinc mines. The dust is either sent to landfill or partly recycled using less efficient technology that has traditionally required a subsidy from the steel industry to be economically viable.
The additional revenue generated by our byproducts and the value added by producing a commercial grade zinc oxide rather than a concentrate enables us to operate profitably even at very low zinc prices. As a result, we're able to guarantee the steel mills a no-cost disposal of their furnace dust at all times. But when zinc prices are higher, we can also pay more for the dust. In this way, we transform a liability for the mills into a profit centre. Full-cycle technology effectively turns an international waste problem into a global resource, and that's very special.
Zincox built its first plant in South Korea for $113 million. Land is expensive in Korea, but recognizing this as a project of national importance, the government bought the plant site for $20 million and granted Zincox a 20-year lease and tax privileges. Construction of the plant commenced in March 2011, and a little over a year later, in April 2012, it produced the first zinc oxide fume. The dust arrives in sealed bulk trailers from all over Korea, is sampled and then assigned to one of 3 silos depending on the grade of zinc contained.
This is the floor where we mix the dust, the coal and the binder. So these are the mixing vessels here. That dust on that slow-moving conveyor is regulating the flow down into this briquetting machine. So as you can see, these are the pockets which work together to create the briquettes. Basically, they're all good quality briquettes or large fragments, all of which are fine in the process. And in fact, there's one final screening before they go into the rotary hearth furnace itself.
The rotary hearth furnace is a circular tunnel with fixed walls and roof and a rotating floor or hearth. It's built on trestles and effectively acts as a very high temperature circular conveyor belt. The dried briquettes are evenly fed across the hearth, which carries them around the furnace at a temperature of about 1300 degrees centigrade. While in the furnace, the zinc and other volatile elements are driven off. Near the end of a full rotation, the briquettes encounter a large auger screw that sits just above the hearth and discharges them to a chute at the outer edge.
Before we put the briquettes into the furnace, they look like this. By the time they've gone through the furnace, they come out looking like that. They've lost their zinc, lead and oxygen, and they're about 60% of the former size. In addition to the removal of zinc, when the briquettes go through the process, they also metallize the iron. So it becomes metallic iron. So while the original briquette is barely magnetic, after they've gone through the process, the briquettes are highly magnetic.
In the full cycle process, the hot briquetted product from the furnace will be sent immediately to an electric melter, where the temperature will be raised to 1500 degrees C, at which point the mixture melts. The iron will sink to the base of the furnace and the other elements will combine to form a free-flowing slag. The slag and iron are periodically poured, with the iron being cast as pigs, which can be used as a scrap substitute or in foundries. The slag can be used as a cement additive or for construction. The electric melter is a standard piece of equipment that is routinely used around the world for the production of ferroalloys. The hot rotary hearth furnace off-gas, which contains fine zinc oxide particles, is drawn off through an outlet on the roof of the furnace. The off-gas is cooled with fresh air, followed by rapid quenching in an evaporative cooler to prevent the formation of dioxins. The cooled off-gas is drawn through filters which recover the zinc intermediate product, a fine powder containing about 62% zinc. The exceptional quality of the fume has been consistently demonstrated in the Korean plant. In the full-cycle Vietnamese plant, this high-quality intermediate zinc oxide will be upgraded by washing out the impurities in a series of leaching and filtration steps. The washing steps create a damp cake that is then sent to a special dryer that disaggregates the zinc oxide and reduces moisture to less than 0.5%. The lead and silver is recovered as a byproduct concentrate containing 85% lead, suitable for sale to lead smelters. The effluent with a salinity close to seawater will be sent to a treatment plant where remaining metals will be precipitated prior to it being sent to holding ponds and, after the composition has been confirmed, released to the marine environment. The upgrading process uses standard equipment at low pressure and only slightly elevated temperatures. The entire plant is monitored and managed by a sophisticated computer control program. Throughout the design process and building on the experience of the Korean operation, considerable effort has been made to prevent fugitive dust and control emissions and effluent discharge. For example, when the silo trucks unload, they do so pneumatically and all conventional conveyors are sealed units. The air quality around the plant is routinely independently monitored so that this can be demonstrated to local stakeholders.
Developing this breakthrough technology has taken a great deal of time and effort, but we now have a game-changing process that makes a positive contribution to the world's steel, rubber and ceramics industries, but which is also good for the environment.